guys. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening. Okay, so this is the second subtopic in this chapter, equilibrium of a uniform rigid body. So at the end of this chapter, students should be able to define torque. Okay, so some other lecture called tau or torque. Okay, both are the same. Torque, moment of a force where the symbol is this one. Okay, torque. It is defined as the product of a force and its perpendicular distance from the line of action of the force to the point rotation axis. So you must remember the distance and the force must be perpendicular. Whatever it is, whatever the angle or whatever the curve or object, the force that acting on the system must be perpendicular with the distance, okay, from the line of action or from the line of the rotation axis. Okay, or we have one formula, torque is equals to Fd. Torque equals to Fd, where torque is the magnitude of the torque, F is the magnitude of the force, and D is the perpendicular distance, okay, moment because of D equals to R sin theta, where R is the distance between pivot point, okay, pivot point is the rotation axis, okay, and the point of application of force, where torque is equals to R cross F, where theta is the angle between R and F, or torque equals to Fr sin theta. So I love to use the first one, torque equals to Fd. Fd only, where D is the perpendicular distance, okay, from the with force. F and D must be perpendicular. It is a vector quantity. The unit of torque is Newton. Okay, F is Newton meter times to distance. Newton meter is a vector product, unlike the joule, unit of work, also equal to a Newton meter, which is scalar product. Torque is also defined as the turning effect of the forces on a body. Sign convention of torque. Okay, if the force is moving anti-clockwise, then it is positive. It is moving, if the force is turning clockwise, then it is negative torque. The value of torque depends on the rotation axis and magnitude of applied force.
Case 1. Consider a force is applied to a meter rule which is pivoted at one end as shown in figures 8.1 and 8.b. 8.1a and 8.1b. So we have 1 meter rule. Okay, this is a pivot point, or we call it as point of rotation. Okay, we have two different forces. The first one, it is upwards. The second one, it is moving at the second quadrant with an angle. So both have the same pivot point, rotation of axis. So this is the distance. It is equals to, and correct for figure 8.1a, torque is equals to Fd, where we can directly times the magnitude of force with the magnitude of D. So what is the direction? It is anti-clockwise. So you can put your thumb here at the pivot point, and this one is the force. So force is moving anti-clockwise. Anti-clockwise means torque is positive. Okay, next, the second subtopic, equilibrium of a uniform rigid body. So rigid body is defined as a body with definite shape that doesn't change, so that the particles that compose it stay in fixed position relative to one another even though a force is exerted on it. So this is example for rigid body lah. So, whatever the force exerted on this bottle, the bottle will stay there. if the rigid body is in equilibrium, means the body is translational and rotational equilibrium. So remember what is meant by equilibrium? The net force will be equals to 0. So there are two conditions for the equilibrium of forces acting on a rigid body. Number one is summation of F equals to F net is equals to 0. And then we need to consider the X and Y axis. Okay, so X, Y and also Z axis. But for our level, matriculation level, only X and Y axis. The second one is the vector sum of all external torque acting on a rigid body must be 0 about any rotation axis. Summation of torque equals to torque net equals to 0. This ensures rotational equilibrium. Okay, equals to 0. This is equivalent to the three independent scalar equation along the direction of coordinate axis. Okay, Tx, Dy and Tz. Okay, another thing that is important is center of gravity, CG. Okay, what is meant by CG? It is defined as the point at which the whole weight of a body may be considered to act. A force that exists on the center of gravity of an object will cause a translational motion. Okay, 8.3 and 8.4 shows the center of gravity of uniform object, rod. So we have one rod. Okay, where is the CG? Center of gravity will be in the middle. Okay, if the length of this rod is 150 cm, that means the distance of the CG from the end of the rod is 75 cm. So dia mesti half dekat tengah-tengah. Sphere refer to geometric center. Okay, so here is the center of gravity of the sphere. So problem solving strategies for equilibrium of a rigid body. Number one, you need to sketch a simple diagram of the system to help conceptualize the problem, and then sketch a separate free body diagram for each body. Normally, you need to sketch one free body diagram for torque and one free body diagram for force. And then choose a convenient coordinate axis for each body and construct a table to resolve the forces into their components and determine the torque by each force. So choose a convenient coordinate axis means you need to choose a pivot point. Okay, normally we choose a pivot point that have more than one unknown force. So no need to construct a table. I will show you step by step how to solve the rigid body question. And then most important, you need to apply the condition for equilibrium of a rigid body. We have two, summation of torque equals to 0 and summation of force equals to 0. And then we can solve the unknown, okay, from the equation. Alright, okay, that's all for today. Thank you guys. Bye. Assalamualaikum.